calculate precision when you've got two measurements side by side, like in this case. You are talking about calculating, in most cases, relative percent difference. And that relative percent difference is calculated by taking one of the things that you're measuring, in this case thermometer A, the value of A minus the value of B divided by the average of A and B. So that will give you a number. In some of our cases we get a number something like 0.30, say, and then if you want to put it in terms of percent, that gets translated to 30%. So that's how you calculate relative percent difference, which is your data quality indicator, relative percent difference of precision when you've got two side-by-side measurements. And you can see that in the first case here, where we measured the temperature both in probe A and probe B to be 4 degrees, the precision error is 0 because it's the same. In this case, you've got 4 minus 3 divided by the average of 3.5. If you look at that, you say, oh yeah, how many times does 3.5 go into 1? About 30%. So here we've got about a 30% difference between the two. And here you've got 5 minus 3 divided by the average, which is 4. So you've got 2 divided by 4, which is about 0.5, is exactly 0.5, or 50%. So here we increase to 50%. So we have something going on here with either our instruments, which seem to be performing fantastically well in terms of their precision error the first time we make a measurement, and then there's a trend where they're disagreeing more and more every time we make a measurement, to the point where it's leveling out about 50% difference between the two, which isn't really what we want to see. So let's take a look at what this would tell us if these were co-located PM2.5 monitors. Now, it may be that having a difference of 50% between your two measurements is okay. It depends upon what you're measuring, what your goals are. If you need to gather a lot of data and your instruments are cheap, but you would prefer to spend your money on buying more instruments that have maybe a pretty bad precision, maybe a precision error of 50% is okay in that case. In the case of co-located PM2.5 measurements, though, it isn't. So what I would do in this case, if this were my site and I had precision results that look like this, say I was just beginning and I was taking every sampling day measurements, and I was starting out to try to figure out what the precision error is before I report the data. And so I've got my stuff going on here, and I'm looking at this and I'm saying, whoa, I would say clearly something happened at this point in time. I would try to find out what happened, what was the difference, did anything change between the first point and the second and third and fourth. And I would definitely say, at this point, I don't think these things are measuring the same quantity. It looks like there's a difference between what they're actually measuring. So in terms of reporting your precision error, I would invalidate these measurements as long as I have enough for my completeness. But I could only do that if I really found some reason to say that there's something that happened here. Or there's some problem with my measurement system that I haven't noticed. So clearly, it seems pretty unlikely, really. Now we've got our ice has melted, but it's still pretty cold. Let's take a look. If we really stir it around and press the reset button on these and keep our probes really side by side, what do we get? Let's make another, before anyone panics and invalidates data or recalibrates, it's always good to make another measurement. So we've got 11 degrees in A and 10 degrees in B. And if I kind of get these even closer together, it looks like they're going to go back both to 11 degrees. So I'm going to take apart my system here and try to figure out what happened. Well, what I noticed is the top of my platform is heightened a little bit, and somebody put a heating pad underneath my ice water bath. So when I had one of these probes down low, it wasn't measuring the same temperature of the water that's supposed to be homogeneous by stirring it as the one at the top. And if I had been more careful and followed my SOP, I would have stirred slowly during. I would have looked at the tips of the probes to make sure that they were near one another. So that's an illustration of how looking at precision error, especially precision error over time, and not just gathering the data, but really looking at it and saying, what does this data mean, can help you identify flaws in your system.